Can a 2.2 millimeter diameter copper wire have the same resistance as a tungsten wire of the same length? Give numerical details. So before we answer this question, let us first try to have a numerical analysis of this problem, so that later on we can really prove if we can really have the same resistance for tungsten and copper given the diameter of this copper wire. So let's have the given for this problem. The diameter of the copper wire, let's say diameter copper equal to 2.2 millimeter, 2.2 millimeter, or this is equal to 2.2 times 10 raised to the negative 3 meters. Then the length of the tungsten wire and the copper wire is the same. Let's say LW for tungsten. So let's just have all these lengths be equal to L. Okay, then we need to prove that the resistance of the copper is equal to the resistance of the tungsten given these details. Okay, so let us try to solve. Can we solve a value for uh, this given these variables to get an equal resistance for copper and tungsten? Well, let's see. So let's have the solution for this problem. So from our resistance equation, we all know that resistance is equal to rho L over A, where R is the resistance, rho is the resistivity, L is the length, and A is the cross-sectional area of the conductor. Therefore, so we need to prove the resistance of copper equal to resistance of tungsten. So this is equal to the rho of copper over, from our given, we'll just have all the lengths be equal to L over area. Now, if this is assuming that this is a regular wire, it is a cylindrical, therefore the cross-sectional area will be a circle with an area of pi r squared, the radius, equal to the resistivity of tungsten, L, pi, radius of tungsten squared. So this is, on the left side is the radius of the copper. Now we can eliminate these values. You can cancel length. It will just be the same according to the problem, and of course the constant pi. So what is left in the equation is just the resistivity constant of copper over radius squared of copper equal to resistivity of tungsten over radius of tungsten squared. Now, as we can see from the given, the radius can be just derived from the given, because the given is the diameter of the copper. So half of the diameter will be the radius. Therefore, the radius of the copper will be equal to 1.1 millimeter, dividing 2.2 by 2. So this would be 1.1 millimeter, or 1.1 times 10 raised to negative 3 meter. If you try to search for the resistivity constant of common materials, the resistivity of copper would be equal to 1.68 times 10 raised to negative 8 ohm meter. And the resistivity of tungsten would be equal to 5.6 times 10 raised to negative 8 ohm meter. So we have now the resistivity constant. We have now the radius of copper. Let's see if we can find a value for the radius of the tungsten wire. Now we can easily solve this by just inputting all these numerical values in our calculator so that we can have a value for the radius of the tungsten wire. So like for example, we just input all these values and use a shortcut to get a value for the radius of tungsten. So we have on the left side of the equation will be the resistivity of the copper equal to 1.68 exponent negative 8 over r squared. The radius would be 1.1 exponent negative 3 squared. Okay, then we have press alpha equals. Then again, the resistivity of the tungsten 5.6 exponent negative 8 8. Then we have the radius of the tungsten. Let's just say that the radius of the tungsten in our calculator is x. So we press alpha, then x squared. Let's see if we can have a value for the radius of the tungsten. So we just have to press shift solve. So the answer, oh sorry, we just need to press, let's just first clear our calculator. We have the resistivity of copper 1.68 times 1.68 exponent negative 8 over resistance of copper 1.1, sorry, radius of copper 1.1 exponent negative 3 squared alpha. Then we have 5.6 exponent negative 8 over x alpha x squared. Okay, shift solve for x. Okay, the value would be 2.0083 times 10 raised to negative 3. So this will be the value, this RW is our X in the calculator. So the radius of tungsten is 2.0083. Radius of tungsten is 2.0083 times 10 raised to negative 3 meters. Okay, so this is for the radius of tungsten. If we'll get the diameter of the tungsten multiplying the radius by 2, we'll just have around 4.016 or 4.017 times 10 raised to negative 3 meters, or This is approximately the diameter of the tungsten will be 4.017 times 10 raised to negative 3. Okay, so let us now go back to the question. So is it possible for a 2.2 millimeter diameter copper wire have the same resistance as tungsten wire of the same length? Of course, the answer will be yes, it is possible, but with a given condition that what? If you'll try to notice, the radius of the copper wire is 1.1. The radius of the copper wire is 1.1 times 10 raised to negative 3. But according to what we have solved, the radius of the tungsten should be 2.008 times 10 raised to negative 3. So almost double the size of the copper wire. Why is it so? Because if you'll try to notice, they have different resistivity constant. So tungsten has a higher resistivity constant compared to the copper. That is why this is also larger, okay, in size. Now, we can try to check. No, we can try to check. And also, we can assume that from this data, the higher the resistivity constant, the higher also, the larger the radius or the diameter. Of course, the area of the cross-sectional area of conductor. We can try to check this if they will have the same resistance given these values that we get. Let's try to check. So just for the sake of checking, we check if we'll get the same values for the resistances. So the resistance of the copper will be rho copper, length of copper over cross-sectional area of copper. Of course, the resistivity constant of copper is 1.68. Let me just input it in our calculator. This is just for the sake of checking. So resistivity constant of copper is 1.68 exponent negative 8 multiplied by, let's say that they have the same length according to the problem. Let's say 1 meter. 1 meter over the cross-sectional area of the copper is shift pi r squared, the radius of the copper, which is 1.1 exponent negative 3 squared, pi r squared. Okay, these values, therefore the resistance of the copper would be approximately 4.419, or this is 4.42 ohms. 4.42 times 10 raised to negative 3 ohms. 4.42 times 10 raised to negative 3 ohms. So this is the resistance of copper. Let's see if we can get the same value for the tungsten. Of course, the resistance of the tungsten would be rho tungsten, length of the tungsten over area of tungsten. Okay, the resistivity of tungsten would be 5.6. Again, we input this in our calculator. 5.6 exponent negative 8 multiplied by the quantity, of course, one length, 1 meter, the same length. Then we'll have area, pi r squared, shift pi times the radius for our tungsten wire conductor is 2.0083. Okay, 2.0083 times 10 raised to negative 3. Of course, I'll square this. Let's see if we can get the same value. Okay, so the answer also is 4.419 times 10 raised to negative 3, or also approximately equal to 4.42 So the resistance of the tungsten wire is also approximately equal to 4.42 times 10 raised to negative 3 ohms. Okay, so we have just proved that they can have the same value of resistances as long as, of course, we adjust the other factors or variables. Like in this case, they can only have the same resistances if the tungsten wire will be bigger in size, because the radius of the copper wire is 1.1 times 10 raised to negative 3, but the radius of tungsten should be 2.0083 times 10 raised to negative 3 meters. So what is the answer? It is possible.